Technology is opening up new possibilities in space exploration as countries race to develop reliable, sustainable and lightweight energy options for use outside the Earth's atmosphere. We follow the team at Rolls-Royce who are using their nuclear expertise to advance groundbreaking technologies that will enable access, power and propulsion in space and back on Earth.
Rolls-Royce has been pioneering technology for more than a century. Its passion for innovation and advancement has created some of the most cutting-edge and exciting developments. And now it's focusing on space. This is Space Park Leicester,
where Rolls-Royce is using this collaborative place to develop innovations for space exploration.
So you know the NCC construction supports thing we're looking at?
With more than 60 years' experience as a pioneer of nuclear technology, Rolls-Royce is developing a new micro-reactor to provide the power for future space missions.
So a bit of a brief overview. This is the main core system, so the fuel will sit in here, be producing all the heat, and then we'll be utilising that heat, bringing it out of the system here to these two areas, and these are the conversion units. That's going to take that thermal energy and produce electrical energy that we can use on the moon.
What is the timeline?
So the objective for the microreactor is to have the first of a kind produced by 2028, with a view that for 2030 it'll be ready for launch. So that's in line with various programmes that, for example, NASA have with Artemis.
Abby Clayton is Rolls-Royce Submarine's Director of Future Programmes. She's excited by the prospect of helping the UK realise its space aspirations.
We're really keen to work with the government to say, actually, what are the missions you want to complete? How would you like to kind of go through that? And actually, we've got such technology superpower at Rolls-Royce with our sort of nuclear heritage. We think we've got loads to offer into that.
Professor Gary Jones is leading Rolls-Royce's nuclear space project.
In terms of technical challenge, we've got over 60 years of creating nuclear reactors for the Royal Navy. And so that capability within our team and that knowledge we can apply onto brand new nuclear products. So this is not the same technology, but the thoughts behind it, the physics behind it, how you bring a product into market, design it, manufacture it, sell it, keep it in service and then dispose of it, all comes as part of our Rolls-Royce know-how. But we are new to space. So we need to build that space profile.
And that's why Space Park Leicester is so important, set up by the University of Leicester as a hub for space technology.
We want to translate the research that we do into impact with value beyond academia. And so involvement and engagement with companies such as Rolls-Royce is essential to deliver that. But we've never had the chance before to have people co-located. And I think that's really exciting because you're all in the same building, you can discuss. And it doesn't just benefit that collaboration and research and turning that impact into value. It's also important for our researchers who maybe have secondments in industry and for our students, sort of enterprise and innovation labs that we can run. Having industry here really is important to us and essential to what we're trying to do.
It's all about the people at the end of the day. So I think with the team we've got behind it, we've got every success.
It's here in the Space Park's clean rooms, where researchers use highly controlled conditions to test the new technology developed for space by teams like Rolls-Royce. Technology which also has the potential to bring benefits much closer to home.
We've got a nuclear renaissance that's happening. We're all aware of the need to drive to net zero, reduce our carbon emissions, get away from fossil fuels, and engineering enables that. And in the UK, Rolls-Royce and many others are working tirelessly on new solutions to work to net zero. And it is a great time to be part of it.
This is actually where we start to see crossover in our technology that we're developing for space, for terrestrial applications as well. So when you start looking at can you decarbonise things like defence estates, get rid of diesel generators, or actually even look at maritime shipping decarbonisation. This is actually crossover technology, so we'd see actually the reactors being 80% common between space and terrestrial applications and really help with that sort of sustainability agenda. The UK wants to be that science superpower, so this is really the bargaining chip, I think, that opens that door.
A chance not just for Rolls-Royce but the UK as a whole to develop technologies for space which also deliver for our planet.